In this video, we're going to take a look at how to find the area under a curve. So there are two fundamental problems of calculus. The first is to find the slope of a line tangent to a curve at a point. This provides instantaneous rate of change at any point on the curve and can be found by finding the derivative. So we found the derivative of a function already. Now we're going to take a look at the second fundamental problem, which is to find the area of a region under a curve. Now, if we're going to estimate the area first using geometry, and then find the area under the curve by finding the integral of the function in the next section. So this is called numeric integration. We're going to find the areas by using geometry. So if the curve is, finding the area is simple when the curve is made of straight lines. So for instance, if you have the graph of a function that's a straight line, and you want to find the area between two values on the x-axis, and beneath that curve, then that figure makes a trapezoid. And there's a formula for area of a trapezoid. It's 1/2 times base 1 plus base 2 times h. So the two parallel sides are the bases. So this would be base 1, base 2, and the distance in between them would be the height. So you would find, so let's take an example for a trapezoid. Let's say that the height of B1 is 4, B2 is 6, and the distance in between is 5. Then the area would be 1/2 times 4 plus 6 times h, which is 5. So we would get an area, 4 plus 6 is 10, half of 10 is 5 times 5 is 25. So the area of the shaded region would be 25 units squared. So if we have straight lines, then we could actually cut this up into several trapezoids and add the areas of each. So the problem comes in calculus is when you have curves and not straight lines. So the area under the graph of f of x from a to b is defined to be the area bounded by the graph of y equals f of x and the x-axis and the vertical lines x equals a and x equals b. And notice what we're going to take a look at is area above the x-axis, so it's going to be positive. So let's start with an example. Estimate the area under the curve of y equals x squared between 0 and 1. So we have a curve, so we can't use a simple geometry formula to find that area. So what we do is something called, we'll start with numerical integration, and then we'll move into how to find the area exactly in the next section. As long as you have a formula for your curve and you can integrate it, then you can find exact area. But if you can't, you have to use a numeric integration technique. So one that we're going to look at from geometry, we know that area is a number that defines the size of a bounded region. We don't know the area under the curve, but we can find the area of a rectangle. So we estimate the area by dividing the area into inscribed rectangles and then add together the area of all the rectangles. So let's first divide our area into 4 rectangles. And being inscribed means that the area is going to be an underestimate. Inscribed means we're going to draw 4 rectangles underneath the curve. They're not going to go above the curve, and find the area of each. So the width of each of these rectangles, if we're going from 0 to 1, then the width is the 1 minus 0, which is the length of the x, divided by 4. So each of these rectangles has a width of 1/4. All right, then how do you find the height of each? Well, our inscribed rectangles, we're starting from 0 to 1/4. The height of the rectangle at 0 is 0. So we have a rectangle. You only see 3 pictured here, but the area of that first rectangle is 0 because the height is 0. The next rectangle has a height. We take f of 1/4, square it, it has a height of 1/16. So this rectangle has a height of 1/16. The next one has an x value of 1/2. So f of 1/2 is equal to 1/4. So that has a height of 1/4. The next rectangle has the height of whatever you get when you put 3/4 in, 9/16. So the coordinates of these points, this point is 3/4, 9/16. The coordinates of this point are 1/2, 1/4. Coordinates of this point are 1/4, 1/16, and then coordinates of this point are 0, 0. So then we find the area of each rectangle by multiplying their length times the width times the height. So the areas we're going to get, the first rectangle is 0 times 0, or I guess the width is 1/4 times 0. The next rectangle is 1/4 times 1/16, then 1/4 times 1/4, and then 1/4 times 9/16. Then an easier way to express that is factor out the width of each rectangle, 1/4, and then add together each of the heights. 0 plus 1/16 plus 1/4 plus 9/16 gives us 1/4 times 14/16, which is an estimate of 7/32 or 0.21875 square units. So that's underestimating by having 4 rectangles drawn and then estimate the area. So notice all the blank spaces up there. So how do you get a more accurate picture? Well, instead of using 4, you can use 10 inscribed rectangles. So notice, if we have 10 rectangles in here, then we have less space. And again, they're inscribed, so they're underneath the graph. So the width of each of these is our total from 0 to 1 divided by 10, so the width of each is 1/10. Then we would have to find the height of each rectangle. So notice there's a lot of computation. The height of each rectangle is taking the 0, each of the x values, 0, 1/10, 2/10, 3/10, 4/10, and putting them in the function so we can figure out what the y value is, because the y value is the height. So we've got a chart that says when you put 0 and each count by 1/10 and square it, f of x is the value. So then we can estimate the area by adding together all of the rectangles. So we get 1/10, which is the width of the rectangle, times each of the heights added together. So the height of the first rectangle is 0, second is 1/10, third is 4/100, etc. And we get an estimate of 0.285 square units. So that's still closer, but still an estimate. So the way that you get a more accurate estimate is by making more and more rectangles in this case. Okay. So an example problem. First, find the exact area under the graph of y equals 3x between x equals 1 and x equals 4. So notice this is going to give us a trapezoid, so we don't need to cut it into rectangles. When x equals 1 and x equals 4 makes this geometric shape. So we need to find the lengths of each of our sides, and then the width or the height of our trapezoid between 1 and 4 is 3. 4 minus 1 is 3. So this height at x equals 1, take f of 1, which is 3 times 1. So that length will be 3. To find b2, put 4 in. We get 3 times 4 is 12. So this length b2 is 12. So we put it in the trapezoid area formula. 1/2 times b1, which is 3, plus b2, which is 12, times the height, the distance in between, which is 3. So 12 plus 3 is 15. 15 times 3 is 45, divided by 2 is the area. All right, so if you want to take a look and estimate area using rectangles, estimate the area of y equals 4x minus x squared between 1 and 4 using 6 rectangles. Here's 1, here's 4. The rectangles are inscribed, and let's see, the width of each rectangle is we take 4 minus 1 divided by 6. 3 over 6 is equal to 1/2. So we're going to have rectangles six rectangles, and then now I want to find the height of each. They have to be inscribed. So the height of the first rectangle is f of 1. The height of the second rectangle is f of 1.5. So here's 1, here's 1.5, so that's the height. The height of the third rectangle isn't f of 2 because notice it would extend above. So inscribed, the height of the next rectangle is what we get when we put in 2.5. The next rectangle would be f of 3. The next rectangle would be f of 3.5. And then the last rectangle is going to have a height of 0, f of 4. So then, after you find the height of each rectangle by substituting it into 4x minus x squared, to find the sum of the areas of each rectangle, we're going to take the width of each rectangle, 1/2, times, add together each of the values that you get. Okay, so what's the fastest way to do that? Use a calculator or use Desmos to substitute your values in, make a table so that you can get each of these. So I'll leave the rest of that one to you. I just want to set it up. Then the last, estimate the area under the graph of y equals 1 over x squared between 1 and 5 for 4 rectangles. So draw the picture between 1 and 5. The width of each rectangle is going to be 5 minus 1 divided by the number of rectangles, which is 1. So the width of each rectangle is 1. And then the height of each rectangle depends. We want to make sure they're inscribed. So we don't want the height of the first one to be the function evaluated at 1 because we'd get a rectangle up above. So f of 2 is the height of the first rectangle. F of 3 is the height of the next rectangle. F of 4, and then f of 5. So when you find the sum of the areas, you're going to take the width, 1, times what you get when you substitute 2, 3, 4, and 5 into the formula. All right, so that helps you set up the problems and gives us one way to estimate the area